Hello everyone. Today we're going to go over the chapter 4 review. So let's get started. Number 1 says consider the sequence. A. Describe the pattern. So just take a look at it. The way I do it is like this. I look at the center, and that does count, okay? And I look at here, there's 1, 1, 1, 1. Then there's 2, 2, 2, 2, 3, 3, 3, and 3. So I'm sure you can assume there's going to be 4 dots at the end. Next one will have 5 dots at the end. Okay? So describe the pattern. A dot is added to the end of each x. Something like that is fine. Draw the next 2 figures of the pattern. Okay? So this one went 1, 2, 3. Next one will have 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. And then the next figure will have 5 on each end. So this has 4. Next one has to have 5. 2, 3, 4, 5. 5. And there you go. There's the 2. This one has 5. Okay. Write a sequence to represent the first 5 figures. Well, okay. So let's see. How many circles or dots are on this one here? 1, 2, 3, 4, 5. Then we add 1 to each end. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see it's growing up by 4. It's going by 4. So this is 13, 17, and 21. 5, 9, 13. There you go. Write a numeric sequence to represent the first 5 figures. Here it is. Number 2. Identify each sequence as arithmetic or geometric. Okay. Then determine the difference or common ratio for each sequence. Okay, that shouldn't be too hard. So let's look at them. From here to here, it goes down by -2. Same thing, -8 to -10, -2. Okay? And that's it. You know that they're adding -2 to the sequence, okay? Yeah, you can add a negative number. So, out of these 2, arithmetic or geometric, which one involves adding arithmetic? And the common difference? Cool. So you can, by looking at it, you can tell that there's no logical sequence. There is a sequence, but it's definitely not adding. So it's probably going to be geometric. Okay? We know it's geometric. And I can't spell. And with geometric comes a common ratio, not the difference. Let's go ahead and do dividing the second term minus the first term. Or divide the second term over the first term. Gives you 0.1. So it is shrinking or getting smaller by a ratio of 0.1. Okay? Pretty straightforward. Letter C. Again, I like to take a look at them first. This is technically 1 over 1. Then the denominator goes by 3's, right? 1 times 3 is 3. 3 times 3 is 9. 9 9 times 3 is 27. 27 times 3, I think, is 81. So let's go ahead and divide these. Or we know it's going to be geometric. And then the common ratio. Again, second term divided by the first term. And remember, I knew it was a common ratio because I was looking at the denominators. How they're growing. 1, 3, 9, 27, 81. Okay? There's no common one number that you can add to all the denominators to get that. So we do the second term divided by the first term. I'm going to write it this way. Second term over the first term. And we turn it into multiplication. Then you flip it. Yeah, I know it's like the same thing, but I got to see every step. And then multiply across. 1 times 1 is 1. 3 times 1 is 3. So there you go. Again, some of you guys might not have to do this step, but I always do it. Taking a look at this one, it goes from 8 to -1 to -10 to -19. I'm going to say it's arithmetic. This time let's find the common difference first. So second term, subtracting the first term. -1 minus 8 equals -9. 8 take away 9 is -1. -1 take away 9, -10. Take away 9. Yep, that works. So we know the common difference. -9. And it's arithmetic. Number 3. For each sequence, write an explicit formula, then determine the 12th term in the sequence. All right? So we had 2 explicit formulas. And that was, for arithmetic, it was A sub n equals A1 plus n minus 1 times the common difference. And for a geometric sequence, we had G sub n equals G1 times R raised to the n minus 1. Okay? Those are the 2 explicit formulas that we had. So let's find the 12th term in each sequence. I'm sure one's going to be geometric, one's going to be arithmetic. Okay. So the first one, think in terms of money. Someone owes you a quarter, then you go all the way to 50 cents. Then you go to $1.25. So from 50 cents to $1.25 is how much? 75? 75 cents. And from here, $1.25 to $2 is also 75 cents. So you know that it's probably going to be a common difference of 0.75. And then from here to here is also 75. So I'm just going to write D equals 0.75. And we thought in terms of money, that's 75 cents. So let's plug it in. We want to find the 12th term. A1 is the first term. Okay, let's do the math. $12 minus 1 is 11 times 0.75, and we just wrote 11 times 0.75. We didn't do anything yet. I like putting the negatives in parentheses. Seven, 5, 8, 2. So we have negative, and I'll write it better actually. So we basically have negative 25 cents plus $8.25. Added up, you just get $8. A sub 12 equals 8. That means the 8th term in this sequence, the 12th term in the sequence is 8. Letter B, 4, 2, 1, 1/2, 1/4. So as you can tell, it's going down by half. It keeps shrinking. So let's find our ratio. We're going to divide this over that. 2 over 4 is 1/2. So we know that's going to be our ratio. So let's do the math. We have our formula up here. G sub 12 equals 4, which is the first term, times 1/2 raised to the 12 minus 1. Okay? G12 equals 4 times 1/2. 12 minus 1 is 11. So that's the same as 2 to the 11th. G12 equals 4 times 1 over 2,048. And the 4 goes on top. 4 over 2,048. We can simplify this. So 4 goes into the top, the numerator, and 4 goes into the bottom. So our answer is 1 over 512. And an easy way to do that is literally just get your answer, like 4 and 2,048. You know they're both even numbers. Cut it in half. 2 over whatever you get. And then if you see it they're even again, take the half again. And you would have ended up with the same answer here. Alright everyone. I hope this video was helpful. See you next time. Peace.